earlier, and if there's time left, I think Dave McComas is going to tack on the end of that a demo, maybe, if there's some time left. So.
All right, can everybody hear me? All right, well, I'm going to have to apologize to everybody who's on WebEx. They've told me that it probably won't be visible for them. So if you see me talking about things, you won't be able to see it, but everybody in the room should be able to see my screen here. I'm a little closer to this screen than the one up there, so if something's too small or you need me to increase something so people in the back especially can see, let me know. I'm just going to go through and, sorry, I'll back up a little bit. Yesterday when I was giving my talks, I talked a lot about and there were a lot of people actually were talking about the CCDD tool. And so, we had some screenshots. So I was just going to try to go through and give a quick demo, sort of give an idea of what it does. Sometimes it's easier to see it in action than it is to actually do it. Or sorry, to try to explain it. So, so this is the CCDD tool. And for today's purposes, I started with a project. You can have multiple projects that you have open. I made one for today called Sample. And it's a very simple project. I have a couple tables that I've defined, one called dummy and one called foo. So I can go ahead and open those, and look at them. So this, is dummy. And this is very much like an Excel spreadsheet interface. You've got a column for your variable name, a column for the data type, so if you want to change this from being a 16-bit integer to a 32-bit integer, that's all you got to do. You basically just define what you need. Description is sort of optional. It's just comments that you can put in. And then, if you want to do an array, you can put, it's 12 items or one item. If you don't leave it, it just assumes it's a singleton item. And that's basically all you need to do to define a data type. And then there's another table. This one is, is much simpler. It doesn't even have anything else. It just has the CCSDS header and then a command count and error count. So that's about as simple as you can get. So, adding items. If I wanted to add a completely new variable, give it a variable name, data type, and then this is actually, I'll talk about it in a minute, but this is for the C++. If you want to have it be a C++, you have to define whether it's a public or private or protected interface. So you've got all that, you click store, and that actually pushes, mentioned before, all the actual database is a Postgres database. So, some SQL calls and things that have to be done. Most people don't have a good knowledge or understanding how to do that. So when you click OK, that basically pushes out to the SQL server. So it's actually done at that point. But this is the only interface most users will ever see. You have the ability to, you can import data. So if you've got a CSV file or something, or a JSON or something, you can pull, a whole table in and do it that way. You can actually directly copy and paste from Excel. If you have these same column names, you can copy this out and put it into Excel, or you can copy it from Excel and put it in. So you're able to work that way. But the thing I think most people were interested in with the tool was the scripting capability. So that's over here. You got so you basically, a script is just there's like 4 different languages, JavaScript or Python or Ruby. It's a script that does anything you want it to. And so you have a set of tables you want to run against. So in my case, I made 2 tables for this particular project. That's however many you want to make. Some of the ones I've built before have 30 or 40 tables, or it just depends on how many apps. So each app, like you would have in CFS, you'd sort of have one table per one. That would be every message that goes on the software bus. You'd make a separate table to describe what that is. And when you want to run a script, so for instance, if I want to do a typesetter, I can run this script and I'll execute and produce the code for me. So if I go look, so it made a footypes.h file. And that's all automatic. I don't have to tell it the name for that. When I run it, it will generate that for me. So, that structure I just showed you inside the CCDD, this is the .h file equivalent built by the script. So it goes through, all these comments on the side, the data size of the array, whether or not it's been telemetered, the overall size of the structure, all this auto-generated. I mean, the database, you saw what I put in there. I mean, it just had the only thing it had was the name and the data type, and then the .h file, generated it this way. Instead of generating a C, and this is a sort of a standard C header file, it's just defining a structure. If you use a slightly different script on the same table, where is it? So there's another one called class header, and so that will make the C++ header for it. It's the same sort of a file. Let's see. Yeah, I just named foo class. So this, let me reload it. Again, since it's now it's in a C++ class, it's defined as a class. It has the defines for whether it's a constructor and a destructor for it. Constructor and destructor for it. A copy macro, and then it actually has the data items in it as well. And they're in the different, depending if they were declared public, private, or protected, they're put in the right section for it. And in this case, actually go through and the header file automatically makes byte swap functions. So this particular one's pretty simple, but depending on the data structure that you had, you could have all kinds of floats and doubles that need to be byte swapped when you're going between things. And so that's a very repetitive task. So you define the script how you build those byte swapping or bit swapping functions, and it will automatically make those. It'll actually go through and reverse the order for the different architectures. So you can define those functions at the bottom, and then in the actual class file, those will be defined. So it has the methods for flipping and reversing the bits. So all that gets built for free, basically. You define that in a script for doing your class headers, and then you can get your header files out that way. Let's see. Another resolution, not the greatest. I keep having to switch back and forth. If you want to do, and that was a pretty simple one. If I go ahead and add in, and it was done with one file. If I go through and do one with multiple, use both of those structures I define, it can execute. And then you'll get, instead of just one file, you'll get both. So now instead of just having one of those files, now it has both files. So it still has this structure in there, but it also has this other one. And this one had substructures that were in it. So I defined an XYZ position structure and a quaternion structure that were used. So in addition to that, it will also define those structures. So when I was only generating this table, it didn't need those because it knew those weren't used and it wasn't necessary. But now that I told it to include this one as well, the tool automatically knows all the children and great-grandchildren that need to be included when you're including a table. So it'll go down as deep as it needs to grab any structure that you need. And it also knows if it's used in multiple places. So if this is the only table that's using quaternion, it puts it right with this table. If there are several applications that all were using that common data structure, it will put that in a shared types header, and so you don't get multiple definitions of it. So it knows whether this is uniquely used in this one place or if it's shared through everything else. So all that's already built into the tool, so you're able to check for that and see if you have something unique or something that's shared. So you're able to go through and, like I said, I put a lot of Doxygen comments in it, so you can use this using Doxygen to get your commenting automatically HTML documentation. And it also puts a lot of stuff as far as who the user was, when it was built, the script that was used to build it, the input tables that it ran on. So if you get a file and you'll go back and look who did it or when, that's already in there. So all that stuff's available, so you can manage that. And I guess the last thing I will say about the tool is it actually has of any software I've used, probably has one of the best guides. So if you go in and there's a user's guide that goes through and shows you how to. It's like 200 pages long. Goes through and actually has screenshots, showing you where all the fields are and how to go through stuff. In addition to that, there's also a tutorial that actually will go through and guide you through the process of building your first table and adding items and doing all that. So for people who are coming up to speed on it or want to learn it, that's been a very nice thing for minimizing the number of questions people have to answer. Yeah.
That's really cool. Is there a connection from the screen you're looking at into the guide? In other words, if I'm somewhere in this process and I click on something, is there a way to have that go directly to the guide?
No, there's a help menu. It's a PDF file. I mean, it's hyperlinked, so you can go, if you're looking for something, it has links that will go down, if I want to edit a table type, you can click on that and it will take you to that section of the guide at the top. But it's just a PDF. It's not. You can't right click, on the tool and get help that way. Although there is some more of a user accessibility kind of a thing. But if you're hovering over a item, like units, it will give you the pop. So you can define all those things. So you can define things and sort of give a, I think it's Section 508 compliance kind of stuff. But all those things have defined fields, and you're able to edit those, and you can put whatever you want inside the database, so it shows up that way.
So I was thinking about the headers, and often as you're developing your project, they'll evolve, and so you put them in version control and then see the evolution. Is there that kind of version control for the tables so that you can kind of look back and forwards in time and see how structured have evolved?
Yeah, that's actually a really good question because, ironically, a database is actually a very hard thing to look at and be able to see changes. If you try to check that into Git or something, it's like a JPEG. It doesn't have a good way to look at those things and see the changes. So in the tool, if you go under the data, you're able to talk about this. You can export your table, so you can, or you can dump the entire database. Where is it? Project backup. It'll actually dump it as a text file, and so that is what we've been checking in on one of the projects I work on. Instead of actually checking in the database because it's a raw binary format, if you export it first, then you get a text file, and it's a bunch of. If you know SQL, you can actually read all the commands, but you can actually see the tables. And so we check that file in, so the database backup text file.
We're actually starting to adopt CCDD, and I'm just curious if there's any resources for extending scripts, generating other files.
So the guide has information on how to use it, all the methods that are available to you. Like I said, it's actually very well documented. Shows you what commands are available. I didn't actually show a script. I guess I could show a script. Maybe that would help with that. Do I have one of those open? Yeah, so here's the script that generates the type setters. And everything is basically, all the methods that are provided start out CCDD. So like, for instance, to get all the structure names, all those tables that I want to run it on, you make the call ccdd.getStructureTableNames by reference order, and that will give you those in order that they were listed when you called it. And so then in your scripting language, that's just a text, list, and so you can use your Python or JavaScript, whatever kind of code you want to do, and that gives you all the tables that you were called with, the number of rows that they had, the stream names. So there's just methods, all these things that start out ccdd.something. These are all well-defined methods that we'll go through, and those are documented quite well to show you what's available. So you never use direct SQL to access the database. I mean, you only have the accessor methods that the CCDD tool provides you. This particular one, so it shows you at the top, I think this is 1.4 something. Yeah, 1.4.26. If you go to GitLab, down and just search for CCDD, it pops up. It's the first thing there, and it will get you the latest version. And Kevin does a great job of keeping that up to date, and he's probably making an update every day or two. So if there are bugs or things that are fine, he's very responsive to make updates and changes to it. So hopefully the versions don't get too, it's not too critical which exact version you're using, as long as you standardize everybody in your team. Occasionally there'll be a major update, and so it will, when you open a database, it'll say, there's been a major update, we need to update your format of your file, and it's no longer backwards compatible, do you want to continue? But that doesn't happen. He tries to minimize how often that happens. So,
Robert, so can you talk a little bit how the system type information gets input in here? Like you have things that are coming out at 10 hertz, but those things are not, you don't want to have to go through and hand type all that in there.
Yeah, so there's a thing, so this is the table. So the table is like an Excel spreadsheet. There's a thing called a field, which you define for it, which has some extra information that doesn't apply to each row of the, it's a global thing. So in this case, you've got a system, a message ID, whether it's a class or not, it's a Boolean, and then the subsystem that it belongs to. So these things down here are the fields, so those things that are defined. So if I want this to be a C++ class, I check the box or not, so that's the Boolean. Everything else I have to type in. So for instance, this thing is given, that's the text name for its message ID, and that's the hex value that the computer uses for that. So those things are defined sort of on a per table or per message basis. And you can pull those out. So let's see, message IDs. So, you can go through and it'll show you all the message IDs that are used. So I had some copy table messages that are in here, and then these are the only 2 messages I defined. So one I gave 1234, 1235. If I was to go through here and change this one, accidentally or on purposely, somebody does this, it'll let me go ahead and change that. But then when I look on here and do my verification for message IDs now, show all IDs, these pop up now. It gives you a bright yellow warning that you've tried to assign the same message ID, and it doesn't stop you from doing it, but it lets you know that you've done that and draws your attention to it. So it does help you with managing those kinds of things.
Yeah, I guess that's not quite what I was poking at. So I have a telemetry rate on virtual channel 1, a telemetry rate on virtual channel 2. Those are all system parameters, and I can't see that somebody's going to have to edit every packet kind of thing. So how do you feed that kind of information in here?
Okay, so this rate column right here tells you the rate. And so, the defined rates for this system are, 10 hertz, 5 hertz, 1 hertz, 2 hertz. So if I say I want to, telemeter this item, say this error code, I want to get it at 5 hertz, or this item, this goes to this is for HK, so for the housekeeping app to be able to go through and cut out the pieces. So you're basically saying, I want this parameter at 5 hertz, I want this parameter at 2 hertz, and the rest of this message I don't care about, so I'm not going to get it. So that's all, you have to save it. So that's how you define that that's the message rate that you want. And then as far as scheduling it, you can go into the scheduling telemetry app over here. And so I don't have any 1 hertz that's unscheduled, but so I've got a 5 hertz. Now this is, it's basically telling me, hey, you have to schedule this still. So I've got a 5 hertz parameter. I have 2 options. I can either put it in message 0, 2, 4, 6, and 8, or I can put it in message 1, 3, 5, 7, 9. It's going to be either even or the odd messages. But it has to fit in all those messages. It shows me how many free bytes are in each of those messages. I mean, this is easy to fit. But if you're getting full, these show yellow or red, when they're not. If I try to assign something that's too big to it. But, I say, okay, yeah, I like that one there. Then I'll add it to that message. And I see what the other one is, 2 hertz. So now I've got, 5 options. I can put it in message 0 and 5, 1 and 6, so it goes, oops. And actually, there's a couple of them that are 5 hertz that aren't assigned. So if I assign both of those, then, I can choose, and it's showing me in green over here which 2 messages it would go in. And I can choose and say, okay, yeah, I like that there, and it'll pull it over. And then if I click on here, I can see everything that has been currently assigned to that message. So I've got 10 housekeeping messages that it can go through, and they each have different contents potentially, because not everything's going to be at 10 hertz. And so it lets you, it keeps track of which one goes where. You store that, and then that's all you have to do. And then the copy table script will use the information that's stored there to generate the copy tables. And if you have multiple streams, like for one of the projects I was on, there's more than one. There'll be more than one tab that'll show up, and so you have to assign each of them separately because they're separate streams. But it's the same process. You go through and you assign the telemetry that you want. Okay.
Yeah, I'll follow up with some other questions later, but.
Thank you. Any more questions? Yes. No? Thanks, Robert.
Right. Okay, we're at it.